Hello, Math 9s. Today, what we're going to do is lesson 8.2 on chord properties. Even though it's not spelt like chord, it's spelled like chord. We call it chord. In 8.1, you should have been doing tangent lines and tangent properties. So, just a reminder of what 8.1 was about. 8.1 was when you have a circle, and everything has to do with circles because it's a circle geometry unit. And you had a line that was outside of the circle that touched it just perfectly at one spot, like that. That purple line was called a tangent line because it only touched one spot on the circle. Awesome. Today, we're going to learn about chord properties. Looks like chord, but it's chord. And we're going to do a few questions together. And you're going to notice that with this unit in circle geometry, we end up just doing a lot of Pythagorean theorem. So if you're kind of still struggling with Pythagorean theorem, it might be smart to just go do some practice before you watch the rest of this video. Just my opinion. Okay, what's a chord? A chord, or a chord, is just a line inside of a circle that connects to two sides of the circle. So if you look over here, we have a couple different chords. This is one right here, technically in orange, because it goes from one side of the circle to the other side of the circle. That ends up being a special chord because that goes through the center of the circle. We call that the diameter, which we'll get to in a second, but it is still technically a chord. This is another chord right here, the red line, because it's a line that connects two ends of the circle. So you could draw infinite chords, right? I could draw one right here. I could draw one way over here. Right? These are all chords because they all go from one side of the circle to another side of the circle. Awesome. That first chord that I did was a special chord. This one right here. That one's special because it goes to the center of the circle. When a line goes from one end of the circle to the other end of the circle and goes right through the middle, we call that the diameter. That should be review for you. So the diameter is from one side of the circle to the other side of the circle, and it goes perfectly through the middle. We also know that if we were to cut the diameter in half, we get the radius of the circle. So if you're looking at that diameter, if we imagine cutting it in half, that means you only have this section right here. That section would be the radius. So that's the distance from the center of the circle to the edge of the circle. And we also talked about that in the last lesson as well. We did a lot with radiuses. Okay, chords. Chords actually have some properties. So we're going to talk about those properties. They're all kind of the same property, in all honesty. They all just kind of link back to each other. So it's just different ways of thinking about chords. The first thing we're going to learn is that when you have a chord, if you have another line, so I'm going to just start to color code these. That's my chord. Okay, so if I have a chord, and I have another line that goes through. Oh, I just got to remember which property. The perpendicular from the center. Yeah, perfect. So if I have another one that goes to the center of the circle, and it goes through my chord like that. So that line doesn't have to make it all the way to the circle edge. It just has to start in the center. Then it's creating a perpendicular line. So perpendicular means it's making 90 degrees. So in this picture over here, we see we have 90 degrees right here. If you have a chord and you have a line that cuts it at 90 degrees, meaning that it is perpendicular, then what you've actually done is you've perfectly cut that chord in half. So this would be 1/2 of the chord, and this would be 1/2 of the chord. We typically do something like this just to show that the lines are equal. So when you have a chord and you have a perpendicular line going through it, it actually cuts the line perfectly in half, and that works for every single chord. So anytime you have a chord and a line going through it at 90 degrees, that also touches the center. It has to go to the center. That's important. Then you've cut that chord perfectly in half. We can reword that rule in other ways. So another way we could say it is that if you have a perpendicular bisector of a chord, so again, my chord is right here. This is my chord. And if I have another line that bisects it, so a bisector of a chord means cuts it in half. So if I have a chord and I have cut it in half, that means that that other line, it cuts in half and creates a 90 degree. It has to be perpendicular. That's important. So it cuts 90 degrees. That line must be going through the center. So even though this question never said it was going through the center, they never labeled it, it must be the center. That's the only way you possibly could have cut a chord perfectly in half and had a 90 degrees. Sorry, my computer just keeps dying really fast all of a sudden. So we'll keep on going and see if that happens again. So you have a perpendicular bisector of a chord. Perpendicular means 90 degrees. Bisector means cuts it in half. Of a chord, which is my red line, it means that other line must have gone through the center. Perfect. Another way we can work this is that if I have a chord, here's my chord. I know it's a chord because it goes from one side of the circle to the other side of the circle. And I have another line that cuts it in half equally, which we see here, right? Cut in half equally. And that line goes through the center, which they've labeled for me. Then it must be 90 degrees. Must be perpendicular. Okay, and that's all they're saying. So those are really the same rule 3 times. If you have 2 of the properties, you have to have the third, essentially. So the properties we have here. The first property is that you're cutting the chord in half. The second property you have is that it must be in the center of the circle. And the third property that you have is that it's perpendicular, meaning making 90 degrees. So if you have 2 of those 3 things, you have to have the third. So if I cut in half and I hit the center of the circle, then it must be 90 degrees. If I'm 90 degrees and I hit the center of the circle, then it must have cut the chord in half. And it works that way. So you always have 2. If you have 2 of them, you have all 3 of them. They all kind of lead to each other. We're going to see how this works in questions like this. Before I get started, I just want you to know circle geometry is hard. It really is. We learn a lot of rules with a lot of definitions and a lot of lines, and it takes a lot of outside the box thinking to be able to do these questions. So if you're not getting it at first, that is okay. That's completely normal. The best way to get good at circle geometry is to just practice and practice and practice, because there's a million different versions of every single question, and you just have to practice to the point where you start to see the rules and see the chords and see all the properties that we've talked about. It's not easy. Okay, so if you're getting frustrated, I understand. All your teachers understand it is hard, but just keep on practicing. That's the only way that you'll get good at these things, is just by seeing the properties over and over and over again. Okay, let's do this first question. It says determine the length of x. So if I look at this question here, x is this gap from here to here. That's x. That's what I'm looking for. There's lots of different ways you could tackle this question. I'm going to show you my strategy for it. So if I were to look at this question, I would notice a few things that I have, and sometimes it helps to write them out. So one thing that I know is they've given me this line right here is 31.8, and that's a special line because it's a chord. It goes from one side to the other side, but it goes through the center. That is the diameter, because it goes through the center. So they told me the diameter equals 31.8. And anytime I have the diameter, that means I must have the radius. The radius is always half of that. So 31.8 divided by 2. And if you throw that in your calculator, 31.8 divided by 2, you should get 15.9 is the radius. Sometimes when you're lost on a question, it helps to see if you know the diameter or know the radius. Because if you know one or the other, then you can figure out the other one, and sometimes that just leads to stuff. For us, knowing the radius actually is helpful, because the radius is actually this distance from the center to the edge. And if you notice, part of that is x, is what we're looking for. So if I know from the center to the edge should be 15.9, from here to here should equal 15.9. And I know that this little section from here to here is 7. Then I could figure out the rest of this from here to here by going 15.9 minus 7. So I go 15.9 minus 7, and I get that x equals 8.9. So that is a question where we're kind of using our knowledge of diameter and radius to figure out the missing part. There is other ways to do that question with like Pythagorean theorem and stuff like that. And if you use one of those methods on your own before me and you got it right, that's fine, as long as you got 8.9. Wonderful. Let's look at the question right next to us. So if you look here, again, the first thing I'm going to do, because I think it's smart, is I'm going to see if I can figure out the radius or the diameter. They've told me from here to here is 12.5. When I'm looking at that, that touches the center of the circle and goes to the edge. That means this is the radius. So even if it doesn't help us, I'm going to write it out. Radius equals 12.5. Never hurts to write out the information you have. If the radius equals 12.5, then the diameter is double that. So the diameter equals 2 times 12.5, which should equal 25. Maybe that helps, maybe it doesn't, who knows. Okay, looking back at my picture, I'm trying to find x, which is this gap right here. If I look, x is actually part of a triangle. So I have that blue line, which I've already highlighted as the radius. I have that green line, which is x, and then I could do this red line right here. So when I notice that x is part of a 90-degree triangle, that kind of tells me, okay, maybe Pythagorean theorem is something I could do here. But you can't do Pythagorean theorem unless you know two of the other sides. And I know 12.5, but I don't know this red side. So somehow I have to discover that red side to be able to use Pythagorean theorem. The way I'm going to figure out that red side is by using my chord properties. So if you look, I have a chord here. I'm going to do it in orange. It goes from one end of the circle to the other end of the circle. And then I have a line that is going through it, that green one, right? This guy right here. And it's connecting to the center, and it created a 90-degree. So because I have a chord, my orange line, and it's being cut by another line at 90 degrees, that is also touching the center of the circle, then I know that this is actually perfectly cut in half, meaning that those two sides must equal each other. So that side over there was 10.8. This side must also be 10.8. Because I had a chord that was cut with a 90-degree that touched the center. And now I can solve for x by using Pythagorean theorem. If you're struggling with Pythagorean theorem, when we're looking for sides, we always have our hypotenuse, which is c. That's the radius in this case. The other two sides I just call a and b. If you're looking for b, that means you use b squared equals c squared minus a squared. So I'm going to throw those things in my calculator or in my formula. So I have x squared equals 12.5 squared minus 10.8 squared. That means x squared equals, I'm going to have to put this in my calculator because I don't know how to do 10.8 squared in my head, 39.61. And then you're going to square root both sides. You're going to notice we do a lot of Pythagorean theorem in this unit. So if you're struggling with Pythagorean theorem, let me know or go get some help from a parent or a tutor or a friend. We're going to say x equals 6.3. And that's our answer. Just because we're going to do a lot of Pythagorean theorem. So if you need help with it, get help now before the end of the unit when we've done Pythagorean theorem for 4 straight lessons and you're not sure how to do it still. Awesome. Let's look at another question. We'll come down here to B. Just to make B clear, 4.3 is this line right here. Before I start doing this question. Okay, let's see what we can do. So The first thing I do is I look to see if I know the radius or if I know the diameter. And in this case, I don't. I'm not sure what the diameter is. I'm not sure what the radius is. So I just kind of have to roll with it. What I do notice, though, is that we have a lot of radiuses here. So like this length is a radius. It's from the center of the circle to the edge. This is a radius, center of the circle to the edge. This is a radius, center of the circle to the edge. And this is a radius, center of the circle to the edge. So all of those side lengths are equal each other. I always do 2 lines through my lines to show that they're equal, but you could do 1 line too to show that they're equal. They're all equal because they're all radiuses, right? So if I could find any of these side lengths, I would find x because they all should equal x. Which is perfect because if you look, I actually have a 90-degree triangle right here. Right, so I could work with that to figure out what that blue x is, and those x's should all be the same. So I have this side right here, which is 4.3. I have this side right here, which is 10.6. I know it's 90 degrees because they told me this side is 90 degrees. That means this side should also be 90 degrees. Awesome. That drew a whole bunch of crazy things on there when I did that. I don't know why it's drawing angle measurements. And I can't get rid of them now. Wonderful. Okay, well, I'll just label it like that. In this case, I am looking for C, right? The C value is the hypotenuse, which is across from the 90 degree. The 90 degree was right there. The other sides can be called A and B. It doesn't matter which one you call which. I'm going to do A squared plus B squared equals C squared. So it means 10.6 squared plus 4.3 squared equals C squared. I throw that in my calculator. 10.6 squared plus 4.3 squared equals 130.85 equals C squared. And then I square root that to get my value of C. Sorry, I'm just going to write that. Square root both sides. My value of C is 11.4, which is my X value. So that's our answer. Wonderful. Okay, last one over here before we start getting into some word problems. This one's a tricky one. Again, the first thing I like to do is if I know the radius or I know the diameter, then I want to write the radius and I want to write the diameter right away. So if I'm looking at this question, I do know from here to here 16.7. So even though it might not help me, I'm going to write that out. I'm going to write radius equals 16.7. If I know the radius, I'm going to write the diameter. So the diameter is equal to 2 times that. So 16.7 times 2, which I'm not going to write this time, is 33.4. It might help me, it might not help me, but it's a good idea in math to always write out the information you know. Right? So I know the radius, I know the diameter, I should write both of them out. Beautiful. If the radius is 16.7, that means any line from the center to the edge should be 16.7. So if I look, this is another radius. So that should also be 16.7. So these two lengths are equal. Awesome. Looking around, I also have a chord. I have a chord that goes from this edge of the circle to this edge of the circle. And I notice this chord is being intersected at a 90 degree by a radius. Because that's happening, that means these two sides must be equal as well. So I could say that this side is 15. Awesome. Now, this is a tricky question. So if you're looking at this, we don't have any 90-degree triangles here. We have a 90 degree, right in here, but we don't have any 90-degree triangles. And if you don't have any 90-degree triangles, it's hard to work with. So sometimes you might just have to create a 90-degree triangle somehow. The way that we're going to do that is by realizing that we know our radius is 16.7. So I could draw a radius anywhere I want, and I know it's 16.7. And if I could somehow connect that so it creates a triangle, that would be even better. So I'm going to draw a radius like that. And I'm going to notice that what I just did was I created a triangle where one side is 16.7, one side is 15, and I don't know the other side. But it's 90 degrees, so I could find that third side by using Pythagorean theorem. I'm going to call this missing side B. The hypotenuse in this case is across from the 90, so that's 16.7 is C, and this other side is A. I'm going to go ahead and calculate B. The reason I'm going to calculate B is because then I would know part of this radius. And if I know this part of the radius, which I'll highlight in green, if I can figure out this part of the radius, then I should be able to find the missing side of the radius, which is the x value. So let's go ahead, let's find B. We're going to do that by using B squared equals C squared minus A squared. So B squared equals 16.7 squared minus 15 squared. So B squared equals, we throw that in our calculator, 16.7 squared minus 15 squared, 53.89. And then I square root both sides. Square root both sides. I get B equals 7.3. Awesome. I can now go back into my triangle and I can label that side 7.3. To find my final x value, which is what it wants, I'm going to realize that this entire radius should be 16.7. And if I subtract away the 7.3 part of the radius, it will leave me with my x value, this part of the radius. So 16.7 minus 7.3 should give you 9.4 equals x. That is a very hard circle geometry question. It caused us to do a few things. One of the things we had to do was create a 90-degree triangle on our own, which will happen a lot. Then we had to do some realization that all radiuses are the same and try to find those radiuses. Then we had to do Pythagorean theorem to find part of the radius, and then we had to subtract to be able to get the final answer. That's a multi-step, high-level thinking question. So if that's hard, that's okay that's hard. Watch it a couple times, practice, and you will get good at them. The more you practice, the more you almost start to see things, right? You'll look at a circle and you'll be like, oh, I see what I need to do. But it comes with lots of practice. Okay, let's try some word problems here. So we have point O is the center of the circle. AB is a diameter with length 26. CD is a chord that is 10 centimeters from the center of the circle. Determine the length of the chord CD to the nearest tenth. Okay, it's always wise to write out what they want you to find. Determine means find the length of chord CD. So I'm trying to find from here to here, from C to D. They've labeled everything else for me, so I don't need to do too much craziness when it comes to solving this because they've kind of told me all the info, but then they drew it in the circle. It's all there. One thing I would like to add is that anytime they give you a diameter, which they did right here, diameter of 26, I like to write that out. So I'm going to say diameter equals 26. That means I could draw radiuses as well. And a radius would be half of that, which is 13. Awesome. Looking at this. I'm trying to find the length of that chord. There's no nice way for me to figure out that whole chord at once. But what I am going to do is I'm going to realize that when I have a chord and it's being cut by a radius because it touched the center. Sorry, not a radius. It's being cut by a line that touches the center. And it creates a 90-degree triangle, that if I could figure out half of the chord, that would be equal to the other half of the chord. They have to be split perfectly in half because of our chord property rules. So now I can kind of focus on, okay, I don't need to find all of CD at once. I could just find half of it and then figure out the rest later. Then I can think to myself, all right, how can I use Pythagorean theorem to make this happen? The way that we do that is by drawing a radius from the center of the circle out to the edge. Actually, I'm going to do this edge over here of the circle and create this triangle where I now have the orange side, the green side is 10, and the red side. And because that's a radius, it went from the center to the edge. I know that radius is 13 because of what I did up here before when I said radius is 13. Then we just need to do a little bit of simple Pythagorean theorem and life will be good. So we're going to call this C because it's across from the 90 right here. We're going to call this A. We're going to say what we're looking for is B. So we're going to do C squared minus A squared equals B squared. That means 13 squared minus 10 squared equals B squared. That should be 69 equals B squared. Square root both sides. And the square root of 69 is 8.3066 and then 23863. I'm not going to write all those out. The reason I'm not rounding it to the nearest tenth right now is because it's not my final answer, right? B was only this length to this length. I'm trying to figure out all of CD. So what I need to do is I need to multiply that by 2. And that would give me the entire length. And because it wasn't a final answer, I don't want to round until my final answer. So I do 8.306623863. I do all those numbers and I multiply it by 2 and I get that 16.6 equals that whole length CD. And I round my final answer now. Wonderful. All right, let's try another one. So this one says, a horizontal pipe has a circular cross section with center O. Its radius is 20 centimeters. Water fills less than 1/2 of the pipe. The surface of the water, AB, is 24 centimeters wide. Determine the maximum depth of the water, CD. Okay. I'm trying to find the maximum depth of the water, CD. CD is from here to here, this little section. Awesome. They did give me some information that they didn't write down. So they said A to B is 24 centimeters. So if I was to go from A to B, this entire thing should be 24. I also know that that thing has been perfectly cut in half. So that line AB is a chord, and that chord is being cut by a line that touches the center and creates a 90 degree. So because that's happening, these two sides must be equal. They must be cut perfectly in half, which means that that side is 12. This half of 24 is 12. With that information, I can see that I've now built a triangle. So I've got that green line there. I've got this orange line here. And I've got that blue line of 12. With a triangle at 90 degrees, I could figure out the missing side over there, which I'm just going to call X for the time being. The reason that would be useful is because I now have a radius, which I know must be 20. From here to here must be 20. And if I was able to subtract away the orange part, it would leave me with CD, which is my little red part. So I'm going to try to work with that. I'm going to do Pythagorean theorem. This is C, this is A, this is B. So if we do C squared minus A squared, it would equal B squared. We're doing 20 squared minus 12 squared should equal B squared. You put 20 squared minus 12 squared in your calculator, and you get 256. Uh-oh, my computer is slowing down really bad here. Should equal B squared. You square root that answer, so the square root of 256 is exactly 16 equals B. What we just found was that this side length is 16. And now when I look at my triangle, I have this line, the yellow that I've drawn. From here all the way to here must be 20 because that's a radius, right? And we know our radius is 20. This part is 16, the orange part. If I want to find this red section in here from C to D, then all I need to do is go 20 minus 16, and that would equal 4. So my depth of the water CD is 4 centimeters. All right. Hopefully you're noticing we need Pythagorean theorem a lot. This question. Radius CD bisects chord AB. Bisects means cuts it perfectly in half. Chord AB measures 8 centimeters. The radius of the circle is 5. Determine the length of CE. Okay, so they have not done any labeling for us, so we're going to have to do that. First thing it says is chord AB measures 8. So from here to here is 8. If that's 8, that means that half of it would be 4. So each one of these little sections must be 4. The radius of the circle is 5 centimeters. The radius of the circle is 5 centimeters. That means from here to here would be 5 centimeters. Determine the length of line CE. CE is this one right here, the orange one. Awesome. By this point, we probably know that we are doing Pythagorean theorem. So if you want to stop this video and see if you can finish the rest of the way and figure out what CE is, that'd be awesome. If you want to keep watching, you're more than welcome. So to figure out CE, we're going to call that X for now. We're going to have to use Pythagorean theorem. This side is C. This side is A. The missing side is B. So we're going to do C squared minus A squared equals B squared. And we're going to substitute our values in. So we have 5 squared minus 4 squared equals x squared. 25 minus 16 should be 9 equals x squared. You're going to square root both sides. And you get that 3 equals x, which is my distance C to E. Easy peasy, right? All right, last one. A circle has a diameter of 14 centimeters. How far from the center of the circle is a chord 8 centimeters long? Okay, so they give you a bunch of info here. Let's start with just talking about what it means. So it says a chord 8 centimeters long. So they never told you where that was, and they never drew it in our circle. So what we're going to do is we're just going to draw a chord. It can be anywhere you want. I'm going to put it right here. But I know that according to this question, that chord is 8 centimeters long. I'm going to want to put it a little lower than that. The whole thing is 8 centimeters. Perfect. What they said is you want to figure out how far from the center of the circle is the chord. So what you're trying to find is this distance right here, from the center of the circle to the chord. How far away is it? If we were to take that line and extend it like this, that would actually be a radius. And because that's a radius, we then know that this is a 90-degree triangle. And I also know I could draw another line that's a radius, so I could create a 90-degree triangle like that. I also know, because they told me that the diameter is 14, that the radius is half of that, so the radius is 7. So I could come over here and I could say, okay, that is 7. I also know that this blue side should be half of 8 because my line was cut perfectly in half. So this would be 4. They asked for how far is the center of the circle to the chord. That means you're looking for x, which is that little gap right there. How far from the center of the circle is the chord? We could do Pythagorean theorem. So we're going to do 7 squared minus 4 squared equals x squared. You throw that in your calculator. You should get 49 minus 16, which is 33, equals x squared. You square root both sides. And you get, square root of 33, 5.7. So the center of my chord circle to my chord is 5.7. Wonderful. I hope you enjoyed some chord properties, circle geometry, lots of Pythagorean theorem, lots of just being able to kind of create your own situations that work for the question. It will take practice. It will be hard. It will be frustrating, but you can get it if you just keep on practicing. Best of luck. Make sure you email us if you need any help, or we could Skype or Google Meet or whatever needs to happen. Best of luck.